Welcome back. So today I'd like to talk a little bit about strings. And you'll see I've created a stub Go file. And let's save it to a string directory. And so if you kind of get your package main, get your FMT import, and start a func main function, then in src, let's create a new folder called something like, let's say string. Okay, and there let's call the function or the program something like main.go is fine, and save it there. And that's going to color code everything nicely because now it's detected as a Go file. And I want us to recall something. So before we saw that you can declare a single symbol variable with the notation var, the name of your variable, and then byte is the type of a symbol. And if you wanted it to be, say, h, the symbol h, then you can use single quotation marks to tell Go that C is equal to that single symbol h. And I don't know if you remember, but the question would be, what happens when we print C? Okay, is just h printed, perhaps without the double quotes? Might be a natural thing for Go to print. Another thing I want to show you is, let's say we convert a number to a string, okay? Then what happens when we print that variable? Is the string 45 printed to the console? So let's try this. Let's save and let's make sure to navigate to that directory that we just created. So we should navigate to Go src and then enter the string folder. And now let's run main.go. See what happens. So we're expecting possibly h and 45, but you're going to remember perhaps that we get actually a number when we print a symbol. Okay, so we declared a symbol equal to h, but then the number 72 gets printed. And then here we see that if we try to convert 45 to a string, then we actually get something extremely strange, which I bet you wouldn't have guessed, which is just a dash symbol or a hyphen. So the question is, why would a hyphen get printed? And why would Go view the symbol h as the number 72? They seem like kind of both very counterintuitive. And we can see that actually, let's see what happens if we give it a string of 72 instead. And what we're going to see is when we run, now we get an h. Okay, and this is a sign as to kind of what might be going on, which is that the lesson is that Go represents symbols as numbers, and it represents strings as arrays of symbols. Okay, so when Go sees the string hello world, it visualizes it as an array, and that array is an array that starts off with 72. That's the integer representation of the symbol h. Then it's 101, then it's 108, and so that 108 corresponds to an L, so we have another 108, and the O is 111, and so on. Okay, and the correspondence between symbols and numbers is called ASCII. Okay, and it's just an old way of unifying the way in which symbols are represented in computers across multiple computers by saying, well, we know that the symbol h is always represented by the symbol 72, for example. Okay, so remember that the symbols have byte type, and so essentially a string is just an array of bytes in Go. It's not the exact same thing, but it's very similar in terms of how it's viewed. So the question would be, what if we really did want to convert the string, the number 45, to a string? How could we do this? Because we're not getting the result that we want. We don't want the symbol that corresponds to the number 45 and convert that to a string, so to give us the dash. We want the number 45 printed as a string. I mean, we could just print 45, but there may be some other application that makes us want to have the string version of 45. Also, I'll recall something that we saw before, which is that os.args stores an array of all command line parameters. So if you try to run a program, go run main.go, and then give it parameters, it's going to store that array as an array of strings. So what we saw is that we wanted to be able to do something like x is equal to os.args, and remember that the first command line parameter is actually going to be os.args of 1, and we want to have os.args of 2, and then we want to be able to print the result of x plus y. That's just a simple example. But if we save that, and then we come to go run main.go, and we try to pass in 4 and 3, you might expect that to print 7, but actually, and what happens is a compiler error because we forgot to import OS. But when we save and rerun, then we see that 72 gets printed. So that was the symbol corresponding to H. String of 45 gives us dash. And now X plus Y gives us 43. And now that's very strange. And the reason is that the array, this is now the string 4, and this is the string 3. So when you use x plus y, it's actually gluing them together. So this is not the number 43, it is the string 43. So for example, it glues them together. So instead, if I had go run main.go, and I had done hello and world, then it prints the string concatenation hello world. So this isn't doing an x plus y, okay? It's doing a string concatenation, and before we saw that if you try to convert to an int, well, Go is going to protect you from trying to pass in hello and world and convert them to an int, and so regardless of what you pass in, it's not going to allow you to just use int of a string and convert it to an int. So to restore our sanity, fortunately, we're going to have a package called strconv, which is just strconv, and I'll let you check out that package online to see the types of functions that it includes, but it allows us to do two things. So for one, strconv allows us to convert between types involving strings naturally, i.e. like what we would expect to happen. So here instead, if we did MJ, and we don't need colon equals because it's already been defined, but instead string convert, and we need to convert an integer to a string. So I to A is the notation, and we have 45. Now if we print MJ, and this will be the last thing that we see, then we should have the string 45. So I'm just going to comment this out for now so we don't get the compiler error. I'll bring it back. And so when we run, OS wasn't used this time. I'll just comment it out as well. When we run, we see that the last thing that's printed here, so 72 and dash were left over from before, but now we actually are printing 45. So before we tried to print string of 45, and it printed a hyphen character, and now it's printing the actual number 45. Okay, so that works completely naturally. If instead we want to fix this, then we need something in strconv that's going to take us from a string to an integer. Okay, and the way that we do this here is to say, let's not do this, but instead let's use strconv. And so we use strconv by doing strconv, and now rather than I to A, it's going to be a string to an integer. So it's A to I, and now we'll take os.args of 1, okay? And the same thing for Y. And so that will take whatever is passed into the command line, convert it to an integer, and store that as an integer Y. So now Y will not have a string type, it will have integer type. But there's just one more wrinkle, which is that if I tried to run this, well, and I used, so if I save and I ran, go run main.go hello world, how would it convert hello and world into integers? So we're back to what I mentioned before, which is that Go doesn't like to have to try and convert something that's clearly not an int to an int. And I need to get rid of OS. But the other two compiler errors are good, which is that it says multiple value strconvert.a2i in single value context. Okay, what could that mean? Well, what that means is that you have a function that's supposed to return two things or multiple things, and you thought it only returned one thing. So if you look at the function a2i in the string convert package, then what you're going to see is it returns two things. It returns an attempt at converting it to an integer, but it also returns a second parameter. Okay, remember functions can return more than one thing, or not a second parameter, but a second output. And that output has an error type. Okay, so we need to declare not just x, but error1 as the result of converting from a string to an integer. Okay, so what happens there is that if, and all you need to know for now is that if the error message is not equal to nil. So if everything goes okay with that, you pass in the number 3, then and string convert converts that 3, that's the first command line parameter, and everything goes okay, then error1 is going to be assigned a value of nil. So that means that if error1 is not equal to nil, there was a problem. Okay? If you make it to here, then you know there wasn't a problem. Okay? If you make it here, all was okay with converting x. All right? So if error1 is not equal to nil, there was a problem. So what we need to do is use os.exit and give it an error code, say 1. And it would be kind of us to print to the user as well, error converting first command line parameter. Okay, and then we're going to do the same thing here, where we simply copy that down, and now we're checking, is error2 equal to nil or not? So if it's equal to nil, everything was okay. If it's not equal to nil, there was a problem. And so let's give an error message and exit with code 1. You could make it code 2 if you like, or some other code if you want to start having different error codes, but that's not really required here. So if we make it here, and I'll add a little negative space, so if we make it to this point, everything was okay with converting y, and now we're good to go. Okay, so let's see what happens. Let's save, and let's go to the command line, and I'm going to pass it in, go run main.go hello world, and when I run, then we're going to see that there was an error converting the first command line parameter after we printed 72 and the dash again, and that tells us the exit status. So we could say, oh, we know I didn't enter the right parameter, and I could go and figure that out. So instead, I could change that to 4, and that'll give us a command line parameter error2 because we wrote that code. But if I give it 2 actual ints and run it, then we see that 7 got printed. So the 45 was the second thing where we converted the number 45 to a string, but that 7 is the result of x plus y, which is what we wanted. So this can be very useful because now you know that you can convert the strings that are contained in the os.args array coming from the command line parameters into whatever you like. So they're going to automatically be strings, so you won't need to convert there. The other two common types would be if you need an int, you can use string convert a to I, as we did here, and I would just say another helpful string convert function for os.args is string convert dot parse float. Okay, and it would take and I'll just do, let's say, z colon equals to and it's going to also have an error. So let's say error3 is equal to string convert dot parse float. And let's try and parse out a string. And let's say it's os.args of 3. And we need to tell it the size of the float. So we always use a float 64, which means it's stored as a big number. There's a lot of storage for that variable. So that's the second parameter in parse float. So you'll typically use 64 here. So we need one more thing, which is if error2 or error3 is not equal to nil. There was a problem converting, and now it's the third command line parameter, and we exit. And instead I'm just going to print z third command line parameter is, and then z. So that meant that everything was okay. So everything's okay with converting z because error must be nil if it reaches here. And so we've been able to pass that in. So I'll come down, I'll save, I'll come down, I'll go run main.go, and now it's got 3 command line parameters. So something weird is going to happen if you run it. You're going to get a syntax error, unexpected z, expecting comma. If instead we give it the right number of command line parameters, then, oh, that was the problem. I had a comma there, okay? So if instead, if we do that, then we're going to get a runtime error, index out of range. Because os.args of 3 didn't exist. We only entered 2 command line parameters, so the name of the program was os.args of 0, os.args of 1 was 4, os.args of 2 was 3, os.args of 3 doesn't exist. So here's an exercise. Think about how you would be able to test to make sure that the user is passing in the correct number of command line parameters so that the user can't break your program with having the wrong number of command line parameters. For now, I'll just give it the right number of parameters. 2.1 would be a float 64. So Go will be able to read that in as a string, then string convert, so parse out os.args of 3 into a float 64, and we're going to print z. Okay, so everything should be fine there. So 72 and dash were our original things. 7 was the result of printing x plus y. So the third command line parameter was 2.1, and that has type float 64, and then 45 was that conversion of the number 45 to a string. So we've got everything working. That's a little bit on string convert, and it kind of restoring sanity when you're converting strings to integers or floats and back and forth. Next time I'll talk a little bit more about strings, and I look forward to talking to you then.